Hello everyone. So in this tutorial, we'll look at circular permutations. Now, if we have five objects, say A, B, C, D and E. Now, if we have to arrange these five objects in a row, then that arrangement can be done in five factorial ways. Now, this is one of the five factorial arrangements of A, B, C, D, E. Another arrangement could be E, A, B, C, D. Here, these two arrangements are considered to be distinct or different. But let us make the same arrangement in a circle or around a table. So, say for example, we have a circle and put these elements or these objects around this circle. A, B, C, D and E. This is the first arrangement. The second arrangement, let us look at the second arrangement around a circle. So here again, so it starts with E, then we have A, B, C and D. So when we looked at the linear arrangement, these two arrangements looked different and were distinct. But when you are looking at the circular arrangement, this two arrangement looks the same. Look here, A, B, C, D, E. A, B, C, D, E. It's one and the same arrangement. So there is no distinction between these two arrangements. So for that reason, when we make the circular permutations depends upon the relative positions of objects. When we say relative positions of object, position of one object with reference to the other objects is known as relative position. So here when we look at A, so A, it's adjacent to A we have E and B. Here also adjacent to A we have E and B, meaning these two arrangements are not different. So for that reason we consider these two arrangements the same. Now what do we need to do in order to make the circular permutations? We have to fix the position of one object. And we have to arrange the remaining objects. And that arrangement can be done in this case we have five objects. So when we fix the position of one object, then we have remaining four objects, and four objects can be arranged in four factorial ways. That is, in this case, so here, in order to make the circular permutations, we have to fix the position of one object. When we fix the position of one object, then remaining we have four objects, isn't it? So four objects can be arranged in four factorial ways. Therefore, number of circular permutations is equal to, since we have fixed the position of one object, so 5 minus 1 factorial ways, which is equal to 4 ways. Fine. Now, in general, so number of circular permutations of n objects is equal to n minus 1 factorial. Hope this is clear. Now when we say the number of circular permutations of n objects is equal to n minus 1 factorial ways. Again, there are two different cases when it comes to circular permutations. Let us discuss these cases one by one. As such, the case number 1 says, case 1, when clockwise and counterclockwise or anti-clockwise, clockwise permutations or arrangements, permutations are distinguishable. Distinguishable. This is case 1. Right? When clockwise and counterclockwise arrangements are distinguishable. Meaning, let's see what is meant by that one. Again, let's take the same picture. So we have things, say we're taking two things. First one, we'll see the clockwise direction, clockwise arrangement, and second one we'll see the counterclockwise arrangement. Okay. So here we have, let's take the same 5 things, A, B, C, D, and E. So these arrangements are in clockwise direction. Okay. First we have fixed the position of A, then we have arranged B, C, D, E. Right? Again, with the fixed position of A, now let's arrange from here B, C, D, and E. Now, if we can distinguish between these two arrangements, first one is clockwise arrangement and the second one is counterclockwise arrangement, then the case or then the number of circular permutations of these objects is as we have discussed in our concept. So that is, we could say this one. So this is the thing. Copy, paste. So if this is the case, excuse me. Let me try once again. I want to fix the position of this one. Anyways, so if that is the case, if clockwise and counterclockwise permutations are distinguishable, then the number of circular permutations, if it is 4 objects, then it is 5 objects, then it is 5 minus 1 factorial ways, and if we have n objects, then it is n minus 1 factorial arrangements will be there. Okay. Now let's look at case 2. When we say case 2, in case 2, let me take this down. So case 2 says, now we just modify this one. Case 2. So in case 2, we will say are not distinguishable. Okay? Clockwise and counterclockwise permutations are not distinguishable. Right? Case 2 says are not distinguishable. If we have to form the garland out of flowers, say garland made out of roses. Say here we have the roses. I'll give the name E M N O P. Fine. And if we turn over this arrangement here, first we have to fix the position of one rose and we have to make the arrangements of the other roses in again like 4 minus 1 factorial ways only, fine. But if I turn over this one, if I turn over this garland, just turn over this garland. So when we turn over, this position of this will be here, but this P will go here. Yes, this N will come here, and O will be here only, isn't it? O will be here only. Meaning it's kind of a, now M, N, O, P. Now it's kind of a counterclockwise arrangement. But here, these two arrangements are the same in the sense that we cannot distinguish between the clockwise and counterclockwise permutations. Okay? If we put this garland in our neck, or put this garland in our neck, we cannot distinguish the arrangement of these two arrangements. In other words, we cannot distinguish these roses, whether rose M is here or rose N is there. We cannot say of these things. So for that reason, we consider these two arrangements the same. And here, for now, we have fixed the position of M and we have arranged the other elements or other roses, isn't it? Yes. But if we fix the position of N and we form the garland, again we will see another different case of the duplicate arrangement. Meaning, if we have n minus 1 arrangements of n minus 1 factorial arrangements, then there will be duplicates. So for that reason, if we cannot distinguish between clockwise and counterclockwise permutations, then the number of arrangements, the number of circular permutations out here, circular permutations, will be equal to n minus 1 factorial divided by 2, because here we will have this, like these two are the same arrangements, isn't it? Yes. So for each of such arrangements there will be its duplicate. So for that reason we'll divide it by 2 and we'll take only the one of the two arrangements. That's why we're dividing by 2. Hope it's clear. And here the cases of such circular permutations where counterclockwise and clockwise permutations are not distinguishable are arrangements. Say first one, you can say arrangement of flowers to form or to make garland, GRLand, garland. Number 2, again arrangements of, we say, bits to form or to make necklace, right? Let me see, LAC, necklace. Number 3 is very interesting. No, number of people. In the previous example, it's kind of number of arranging the people in around the table. Okay, so here we're saying arrangement of people so as not to have the same neighbor, NIGH, same neighbors. So this is another interesting circular permutations. Okay, let's look at this one. Case 3, not case 3, the example 3. We're saying we're looking at this one. So let's look at this. Now, let's keep it there. So when we say arrangements of people so as not to have the same neighbor, so I'm saying again, I have here neighbor 1, people 1, no? Then neighbor 2, neighbor 3, neighbor 4, and neighbor 5, right? So another arrangement. Let us say we have fixed the position of neighbor 1. So neighbor 1 will be here only. Just change the position out here. So in place of neighbor 2 here, I'm keeping neighbor 2 here. Then here I have neighbor 3. Here I have neighbor. And here I have neighbor 1, 2, 3, 4. It is 5. That's why I've confused. So here we have neighbor 4 and it is neighbor 5. Right. So in these two arrangements, our condition says we should not have the same neighbor. Yes. In our arrangements, we should not have the same neighbor. But look at these two arrangements. So here we have neighbor 1 and his neighbors are neighbor 2 and neighbor 5. In this case also, we have neighbor 1, his neighbors are neighbor 2 and neighbor 5. So in both the arrangements, we have neighbor 1 is having the same neighbors, but our condition says this neighbor, the people or the particular person should not have the same neighbors. So for that reason, even in this case, number of circular permutations, I'll say required number. No? Required number means whenever I say required number, we are talking about the condition. Condition out here is there should not be same neighbor, isn't it? Required number of circular permutations in above case is equal to 5 minus 1 factorial divided by 2, which is equal to 4 factorial divided by 2. Whatever value you get will be the number of arrangements when we arrange the people so as not to have the same neighbors. Hope it is clear. Thank you. We'll meet in the next video.